Hello students and welcome to the lecture on Introduction to Artificial Intelligence. The second lecture in the lecture series for the course of Introduction to Soft Computing for the Electronics and Telecommunication Engineering students of the 7th semester Goa College of Engineering. I am Ms. Purti Savardekar, the faculty in charge of this course. What exactly is artificial intelligence? There have been a number of attempts to define it, but arguably, we may consider this definition. Artificial intelligence is the study of how to make computers do things which at the moment people do. We notice that there is a reference to the current state of computer science, which we all know keeps evolving. So, this definition remains applicable in time because, as someone has said, AI is artificial intelligence only till it is achieved. And once it is achieved, the acronym returns to and reduces to already implemented. Then there is next intelligent action that is to be achieved. A human being learns the skills in a standard order. For example, first comes the vision, then the speech, then understanding a language, then common sense reasoning, etc. After this, expert skills such as engineering, medicine, or finance are required. It might seem to make sense then that earlier skills are easier, therefore, might be easily computerized compared to the later ones, more specialized ones. For this reason, much of the initial AI work was concentrated in those early areas. But it turns out that this assumption is not right. Although expert skills require knowledge that not many of us have, the amount of knowledge required for expert skills is very, very less compared to the amount of knowledge that is required to do the mundane tasks. Expert knowledge is actually easier than mundane knowledge to be represented and dealt with using programs. That is why the problem areas where AI is currently flourishing the most are primarily domains that require only specialized expertise without the assistance of common sense knowledge. Where can a problem solving technique or when can a problem solving technique be called an AI technique? Let us consider a problem of, say, playing a game, say the simple game of tic-tac-toe. Let us assess 3 ways in which programs may be written to solve the problem of tic-tac-toe. Let us write the programs to make the moves for both players one at a time. One method to implement this that comes to mind is to firstly have a data structure that represents the board and its 9 locations. We could have an array, say of size 9 or 3 by 3. Then, how to identify a certain move? What is a move? A move is basically a change in the values at the locations of that array. That means an entry at a location in the board is an entry at a location in the array. Okay, but what entry? X or O? And then how to show blank entries? We can identify a blank entry as a 0, X entry as a 1 and O entry as a 2. Now, making a move is equivalent to changing the state of the board from its current state, say 0, 0, 0, 0, 0, 0, 0, 1, 0 to 0, 0, 0, 0, 0, 2, 0, 1, 0. That means we will have to have a list of all possible states. For every current state, there will be an appropriate corresponding state. We can have a complete list of moves stored in a data structure called, say, moves. The next move to be made can be stored as an entry in that moves array. Okay, since 0, 1 and 2 are total 3 values, and the array is an 9 element array, obviously there will be 3 raised to 9 possible states. 3 raised to 9 total possible states of the board. We can have an array of a size 3 raised to 9, where the current state becomes the index into the array, and the next state to be made a move of, the next state is the entry at that index. For example, here this position can be converted to a base 3 location. That location, the base 3 translation, becomes the index in the moves table. We check that index in the moves table, and the next move will be the entry at that index. I hope that the idea is clear. Now, the programmer has to have some patience into preparing this moves table very, very thoughtfully. The algorithm is only going to translate the current state into a base 3 number, search the moves table for this index, retrieve the next move, and make that the current state. That will get repeated till the state becomes such that one of the final states or goal states, like 111, 020, 202, is achieved. This is one way of making the computer play a game. This game of tic-tac-toe. Is this an AI technique? Of course, here the programmer in designing the moves table has done most of the thought process. The computer is not thinking. The computer is not making decisions. It is only translating. The second method, which may be an improvement, could be to again consider a board data structure. But now we do not have the moves table. That was the problem in the last method. Now let us have a variable called move number. Move number. We know that the game of tic-tac-toe finishes in 9 moves. So move number will store the move number. That is, it will be initialized to 1 and incremented by 1 every time a move is made. Okay. To solve the problem, we design the algorithm using if and else conditions. Here, we may write the code to check the individual position on the board, not the entire state of the board at once. For example, like how a human would check the center position if it is already marked, and then they would mark the corner or a non-corner position. So the algorithm will also check the locations in a particular order of priority. First they will check for the center cell, then they will check for the corner cell, then they will check for the non-corner cell, etc. and return a location. And then, depending on whether it is an odd turn or an even turn, mark that position with either an X or an O, till finally the goal state is achieved. This is another way of making the computer play the game. Is this an AI technique? Is the computer thinking? Here now we have specified the rules of the game to the computer, like what the move should be if a certain position is marked. The computer is choosing the rule to be applied by checking the state of the board. Here at least the computer is making a decision. Some more responsibilities of the back of the programmer, but not all the responsibility. The computer is not doing this on its own. Now consider a third method. In this method, to decide the next move, the algorithm looks ahead at the board positions that result from each possible move. It decides which position is the best and makes that move the one that leads to that position. At this point, I'd like you to pause the video for a minute or two, go through the game screenshot that is drawn and understand the method that is proposed. A method of this kind would need a 9-element array called board, a list of all possible board positions called states, a graph connecting a state to all the next possible states, a list of goal states. Every time a move is to be made, the algorithm will create a tree of possibilities and choose the move that returns the best chances to win. Is this an AI technique? This procedure will obviously require more time because at every step an entire state tree has to be generated to find the best move. But it is superior to the other programs in a very big way. The same algorithm can be extended to handle games that are more complicated than tic-tac-toe. In most cases, games where previous two approaches would completely fall apart. That would be hard coding. This indeed is an example of an AI technique. The computer is thinking and making a decision. One of the most important questions to answer here is, how will we know if we have constructed a machine that is intelligent? Alan Turing in 1950 designed the Turing test to answer this question. To conduct this test, we need two people and the machine that is to be evaluated. One person plays the role of the interrogator, who is in a separate room from the computer and the other person. The interrogator can ask questions to either the person or the computer by typing the questions and receiving typed responses. However, the interrogator knows them only as A and B and aims to determine which one is the person and which one is the machine. The goal of the machine is to fool the interrogator into believing that it is the person. If the machine succeeds at this, then we will conclude that the machine can think. The machine is allowed to do whatever it can to fool the interrogator. So for example, if asked the question, how much is 12,324 times 73,981, the machine could wait for several minutes and then respond with the wrong answer. We will continue this discussion about artificial intelligence in the next lecture. See you now at the live classes on Google Meet. Thank you.